Okay, so today we're going to be talking about epoxies as high performance materials and as adhesives. So epoxies were first synthesized in 1891, but they were actually not commercially available until 1946. They were first kind of made, well, the credit for it gets shared between Dr. Pierre Castan in Switzerland and Dr. Sylvain Greenlee in the United States. Castan was licensed by Ciba, and they're one of three major epoxy resin producers in the world. And then Greenlee worked for DeVoe Reynolds, which was later bought out by Shell Chemicals. And Shell, they were the first ones, but later in the 1950s, Dow Chemical as well as Reichhold Chemical joined in to the epoxy business, if you will. So epoxies are polymerized with oxyrane rings and a glycetyl group, typically. They are mostly made with a condensation reaction of epichlorohydrin and bisphenol A from the DGEBA process, which is also known as the taffy process, because during the process it forms a substance that is very similar in texture to taffy. So it takes about 2 to 3 hours for the whole process to take place, and that's at 100 degrees Celsius. It's actually an emulsion polymerization, and it's a reaction between the resin and sodium salt. And after the polymerization, the resin is dissolved and the salt is filtered out. So epoxies are really popular for high performance applications. They have a high melting temperature as well as a high heat deflection temperature, which makes them very good for the aircraft and aerospace industry. They can withstand high temperatures and cold temperatures, which is really good because for a typical passenger jet like a 747, the cruising altitude is between 35,000 and 40,000 feet, and temperatures that high can be as low as negative 70 degrees Celsius. So the epoxy needs to be able to withstand that big temperature change from landing and taking off and then getting up to cruising altitude, because you don't want the epoxy to become brittle and essentially shatter. And so epoxies also have good flexibility, impact strength, overall toughness, thermal properties, as well as chemical resistance. Epoxies are also very good for adhesives. During their curing process, the oxyrane rings or glycetyl groups open to make polar OH bonds, which adhere to almost anything. They can be cured at room temperature, but you can also have a quicker cure time if you add heat. So if you put them in, say, an oven, or possibly even just use a hair dryer on them, it'll increase their cure or decrease their curing time. They also have very good chemical and corrosion resistance, and they don't absorb moisture. They can also bond to just about any surface, whether that be metals like steel and aluminum. They bond to other thermoplastics. They bond to wood, brick, and so many other different surfaces. So they adhere to porous and non-porous surfaces. They can also be used between negative 57 degrees Fahrenheit temperatures and actually over 500 degrees Fahrenheit. So really they can be used in any kind of adhesion application that you would need them for. They're also used a lot in marine applications like boats and things like that. But that's just a little bit of information about epoxies for high performance materials as well as adhesives. Thank you.